let's look at another example. This one is going to be one that's going to end up being no solution at the end, and I want to show you why. First off, to begin with, we are still looking to get a common denominator here, and that does mean we want to factor each of our denominators as far as we can to figure out what that common denominator would be. Well, x minus 4 is certainly already factored, and x minus 2 is also already factored. But x squared minus 6x plus 8, now that is something we can factor further, specifically using our ABC x method style of factoring, right? So we would be looking for two numbers that multiply to 8, positive 8, but add to negative 6, which in this case would be a negative 4 and a negative 2. Meaning we could factor this to x minus 4 and x minus 2. When we do that, now we can see a little bit clearer what our common denominator would be. Because here's all my x minus 4s, and here's all my x minus 2s. I notice that my second fraction has both x minus 4 and x minus 2. My first two fractions only have one of each. So a common denominator would be to have all three of our fractions have both the factor x minus 4 and the factor x minus 2. So we'd take the first fraction of 1 over x minus 4 and we will multiply in our own x minus 2. But to do that, we have to do that on both top and bottom, numerator and denominator. Looking at our second fraction, I already have x minus 2 in the denominator, so we would want to multiply in an x minus 4, the thing that we're missing. And then for the third fraction, we're just rewriting that, right? Nothing special going on there. And so the idea is now every single fraction has an x minus 4 in it and an x minus 2 in it. Right? All three of my fractions have both those factors. So all we need to do is multiply the numerators. Well, 1 times x minus 2 is just x minus 2, because 1 is always pretty easy to multiply with. With our second fraction, we do need to distribute this 2. So 2 times x would be 2x. 2 times negative 4 would be negative 8. But again, that does give us now both of the factors x minus 2 and x minus 4. And so, now that we have got everything multiplied together and we have three complete fractions that all have the same denominator, we can ignore the denominators and just solve the numerators, just solve the tops. Meaning we have x minus 2 plus 2x minus 8 equals 2. So I would probably take x plus 2x to give us 3x, and take negative 2 minus 8 to give us a negative 10. So then to solve that out, we would add 10 over, giving us 3x equals 12, and then divide by 3 to give us x equals 4. And all that comes out nicely. We do get an answer of x equals 4. Here's the reason why this is not going to give us an actual answer, why this is actually no solution. If we say that x equals 4, if that's what we're saying our answer is, take a look back at our original problem, at our original equation. If I plug 4 right here, if I plug in x equals 4 right here, that means we would have 4 minus 4, which would give us 0, meaning this fraction right here would be 1 over 0. As you guys know, anytime you divide by 0, you get undefined. And so because of that, if one fraction becomes undefined, the whole thing would be undefined, no solution. And so we can't have an answer of x equals 4, because when we plug 4 back in, it doesn't work. But 4 is the only number we came up with our math, so we can't get another answer, and this answer doesn't work, which means we are forced to say that there is no solution for this problem.